Hello everyone, welcome to Study Made Easy, a smart learning for a smartphone generation. Now in the last videos, we have talked about acceleration, equations of motion, velocity, speed and distance. Now in this video, I'll be discussing some problems with you so that you can have a better understanding on what we have learned so far. So let's move and discuss the first problem. Now the first problem says that a ball is thrown in an upward from the top of the tower of height h. At the same time, ball B starts to fall from that point. When A comes to the top of the tower, B reaches the ground. Find the time to reach the maximum height for A. So let me explain the question for you. Now the question says that we have a tower of height h. Let me draw that. Sorry, my drawing is not so appropriate. I have a tower of height h and we have two balls, ball A and ball B. Now ball A, let me assume, is thrown upward with an initial velocity of u meter per second. Now since ball B actually falls from the point, we can say that its initial velocity is equal to 0. So what does the problem say? The problem says that ball A is thrown upwards and after some time it reaches to its maximum point and it again turns and returns to its original position, and at that time the ball B has reached the ground, right? So actually the question says that the time taken by the ball to again come back to this position will be equal to the time taken by the ball B to reach to the ground. This is what this thing means, right? Now we need to calculate the time taken by the ball A to reach the maximum height. So before solving the question, let me tell you the sign conventions that I'll be using for this question. Now actually this question is of the problem of free fall. Now in the free fall, acceleration is always equal to the acceleration due to gravity, and the sign conventions are that if an object will be moving upwards, acceleration will be negative g, and if the ball will be moving downwards, the acceleration will be taken as positive g, right? So let's move and solve the question. Now let me draw here the ball. This is ball A and it is thrown with the velocity of u meter per second, right? Now after some time the ball will definitely reach to its maximum position, right? Let me say this is the maximum position. Now at this position, since it is the maximum position, the ball actually will stop there for some time, right? So I can say that its velocity at that moment will be equal to 0, and that will be its final velocity. So if I write the first equation of motion for my ball A, what I will get is that VA is equal to UA plus A into T. Now since the final velocity of an object is 0, initial velocity is u, and since the ball is moving in upward direction, I will take acceleration as minus g and t will be as it is. Now if I rearrange this, I will be getting minus u will be equal to minus g into t, and minus and minus will cancel out, and I'll get t as u over g, right? Now the actual answer of this question is actually t square root of h over 2g, but we are getting t is equal to ug, so we have to make some substitutions in this equation so that I will get an appropriate answer of square root of h over 2g. Now to make this substitution, I'll use the question what it says. Question says that when A comes to the top of the tower, ball B reaches the ground. Now I have already told you that this simply means that when ball A, after returning from its highest position, again comes to this point, the time taken by this process will be equal to the time taken by the ball B to reach to the ground, right? So what will be the time taken by the ball A in reaching back to its original position? We need to calculate that first, right? Now, if you carefully notice that ball A, when it is projected with with a velocity of u, it reaches to its maximum point at the time of u over g. Now, the ball will again come back to its original position in the same time. So the total time will be simply equal to u over g plus u over g, right? Now first u over g is the time taken by an object to reach to its highest point, and the second u over g is simply the time taken by an object to again come back to its original position, and that will be equal to twice u over g, right? Now we'll calculate the time taken by the ball B to reach the ground. Now this can be easily calculated by the second equation of motion, and that is SB for ball B, the distance traveled by the ball B, is simply equal to initial velocity into time t plus half of AT square, right? Now the distance that the ball B has to travel from this position to reach the ground is simply h. So for SB I can write h, and since the initial velocity of an object B was taken as 0, I'll write this as 0, and this will be equal to simply half of gt square, right? So if I rearrange this, I'll be getting t as simply square root of 2h over g, right? Now from our question, this time is simply equal to this, right? So I can write twice u over g as equal to square root of 2h over g, right? So my u will come out to be simply square root of twice h over g into g by 2, right? So this is my u, or I can say my initial velocity. Now if I substitute the value of u in this equation, I will get the required equation which I have to calculate. Now that can be calculated simply that t will be equal to u over g, but our u is simply equal to twice h over g into g by 2 whole divided by g, right? Now simply this g and this g will cancel out, and I'll be left with t equal to square root of twice h over g into 1 by 2, right? Now what I will do is that I'll rearrange my equation, right? Now how can I do that? I can write t as square root over h over g, and this 2 I will write here, right? I can write this way. Now if I multiply and divide numerator and the denominator by square root of 2, now this square root and this square root will become square root whole square, and root and square will cancel out, and I'll be left with 2, and that 2 will cancel out with this 2, and I will be simply left with t will be equal to h over g into 1 by root 2. Now this again can be rearranged, and my answer will become simply h over 2g. right? So this is my final answer, and actually we needed to calculate this answer, right? So I have nothing but substituted the value of u in my equation to get an appropriate answer. Now let's move and talk about the second question. Now the second question says that a particle starts from a point whose initial velocity is v1 and it reaches with a final velocity v2 at the point B, which is at a distance d from point A. The path is a straight line if acceleration is proportional to velocity. So let me highlight this. Acceleration is proportional to velocity. Find the time taken by the particle from A to B. So what the question says is that we have a point A and we have a point B. Now the velocity of an object at the point A is simply v1 and velocity of an object at point B is simply v2. Now the distance between AB is simply d, and I need to calculate the time taken by the particle to reach from A to B. Now in order to solve this, the question says actually that acceleration is proportional to velocity, right? So I can write acceleration is proportional to velocity, right? Now if I remove this proportionality constant with a simple constant, what I will get is this, right? You might have read this in elementary school. Now since acceleration is simply equal to the rate of change of velocity with time, I can write acceleration as dv by dt, and c can be written as it is, and v will be written as it is. Now let me call this equation first, right? Now I'll rearrange the equation and I can get simply this equation if I rearrange it, right? If I rearrange equation y, I'll be getting this, right? Now I'll integrate the left hand side from v1 to v2, and I'll integrate the right hand side from 0 to t, and let's see what we get. Now if I integrate the left hand side, now this is nothing but ln of v, so it will be simply ln of v under the limits from v1 to v2, and since c is constant, it will be taken out from the integration, and I'll have to integrate only dt, right? Now this is nothing but ln of v2 minus ln of v1, and here d and integration will cancel out and you'll be left with simply c into t, right? So the time taken by the particle to reach from A to B will be simply t will be equal to ln of v2 minus ln of v1 over c, right? But this is not my final answer. Actually, I have to make some substitutions so that I can replace c with something else. Now in order to do so, I'll focus my attention on equation first, and I can rewrite equation first as dv over dt can be equal to c into, and velocity can be written as rate of change of displacement with time, right? Now here dt and dt will cancel out and we will be left with simply dv will be equal to c into ds, right? Now I'll again integrate the left hand side from v1 to v2, and I'll integrate the right hand side from simply 0 to s, right? So what I'll be left with is this, and this will cancel out and v will be under the limits from v1 to v2, and c will be taken out from the integration and you have to integrate simply ds. Now this and this will cancel out and this will be equal to nothing but v2 minus v1, and this will be equal to nothing but c into s, right? So our c from this comes out to be simply v2 minus v1 over s, right? So if I put my C in this equation, I'll get an appropriate answer for my question, and T will come out to be simply ln of V2 minus ln of V1 all divided by V2 minus V1 divided by S. Or I can rewrite it as T will be equal to simply S into ln of V2 minus ln of V1 over V2 minus V1, right? So this is our answer for the second equation.